A is equal to cos of pi by 4 pi by 3 plus I sin pi by 3. So your theta is given as 4 pi by 3. Then the value of 1 plus A upon 2 raised to 3n is equal to 1 plus cos of 4 pi by 3 plus I sin 4 pi by 3 upon 2 raised to 3n. So what you get is 2 cos square 2 pi by 3 plus 2i sin 2 pi by 3 2 cos pi by 3 upon 2 cos 2 pi by 3 cos of 2 pi by 3 plus I sin pi by 3 3n. So that is minus half raised to 3n cos of n pi plus I sin 2 pi n. So minus 1 raised to n upon 2 raised to 3n into 1 plus 0. So the answer is minus 1 raised to n upon 2 raised to 3n. Answer is B. The closest distance of the origin from a curve given by alpha conjugate of z plus, that is bar z bar x into z plus modulus of alpha square is equal to 0. And the answer is D. How you get this? D is equal to alpha into 0 plus 0 into alpha bar plus a square modulus upon 2a, that is equal to a upon 2, and that is nothing but alpha. Okay. Sine inverse of 1 upon I 2 minus 1, where z is a non-real. It can be angle of a triangle if following are the options. So z minus 1 upon I is equal to x plus yi minus 1 upon I, that is equal to y minus x minus 1i. So for z minus 1i to be real, x minus 1 is equal to 0. So sine inverse of 1 upon I is z minus 1 is equal to sine inverse of I. So minus y is between x is equal to 1. The answer is real part is 1 and it will lie. Imaginary will lie between minus 1 and plus 1. If z is equal to root 3 plus I upon root 3 minus I, then the fundamental amplitude of z will be, so z is equal to root 3 plus I upon root 3 minus I, taking the conjugate of the denominator. When you solve, you get root 3 plus I the whole square upon root 3 square a square minus b square. Once I solve this, I get this as half plus root 3 upon 2i. So that is a plus bi. So real, imaginary. A is half and b is root 3 upon 2. And then I have to find amplitude, that is tan inverse of b upon a. We get this as tan inverse of root 3, and that is nothing but pi by 3, that is C. If infinity is not equal to 1 and it is a cube root of such that I'm following big equation 1 upon a plus infinity upon 1 plus b upon infinity plus 1 upon c plus infinity is equal to 2 infinity and 1 upon a plus infinity plus 1 upon b plus infinity plus 1 upon c plus infinity is equal to 2 infinity. Then value for 1 upon a plus 1, 1 upon b plus 1, 1 upon c plus 1 is equal to. So clearly we know that both are roots, and 1 upon a plus infinity plus 1 upon b plus infinity plus 1 upon let's say c plus infinity, this all is equal to infinity. Okay, after this anything else, so you get as to infinity, yeah, let's say infinity. Now 3 infinity cube plus 2 a plus b plus c infinity square plus bc plus c plus ab x cube plus a plus b plus c bc plus abc. So x cube minus bc plus ca plus ab. This is your infinity, this is your infinity, this is also your infinity minus 2 abc. So answer will be 2. If alpha is a root of x raised to 7 minus 1 and it is not equal to, so alpha raised to 101 plus 102 plus 205 you get as alpha 101 alpha 105 minus 1 upon alpha minus 1, so this is equal to 0. If it is a cube root of unity, then cos of 1 minus infinity 1 minus infinity square plus 10 minus infinity into 10 minus infinity square pi upon 900 is equal to, so k minus infinity k minus infinity square is equal to k square minus k into infinity square. So summation of 10 k1 k minus infinity k minus infinity square is equal to k square plus k plus 1, that is 10 into 11 into 21 upon 6 plus 10 into 11 upon 2 plus 10 is equal to 450. So that is cos of 450 into pi upon 900, that is equal to cos pi by 2, that is equal to 0, because this gets multiplied. So your answer is 0. Again, if 13 summation n equal to 1 I raised to n plus 13 summation n equal to 1 I raised to n plus 1 is equal to I plus I square. The extent of I raised to 13, what you get is I into 1 plus I raised to 12 plus I square I minus 1 1 minus I raised to 30 upon 1 minus I. Value for I minus 1. The answer is B minus 1. Z1 plus Z square plus 1 is equal to 0. It's given. Your Z will be equal to infinity, or let's say the square. So Z plus 1 upon Z is equal to minus 1. Your Z plus 1 upon Z square is equal to infinity square raised to 4, that is equal to minus 1. Z cube will be raised to 6 raised to 3 equal to 1 plus 1, that is equal to 2. Similarly, Z raised to 4 plus 1 upon Z raised to 4, that is equal to that is again minus 1. Similarly, Z raised to 5, 1 upon Z raised to 5 is equal to minus 1. Z raised to 6 plus 1 upon Z raised to 6 is equal to 2. Therefore, the required solution is 1 plus 1 plus 4 plus 1 plus 1 plus 4, that is equal to 12. If W is equal to alpha plus I beta, where beta is not equal to 0 and Z is not equal to 1, satisfy the condition that Z minus Z modulus of ZW upon 1 minus Z is purely real, then the set of values of Z is W minus modulus of ZW upon 1 minus Z is equal to modulus of W minus W modulus of Z upon 1 minus Z, that is equal to Z modulus of Z minus 1 W minus modulus of W, that is equal to 0. But W is given as alpha plus I beta, and that will not be equal to modulus of Z. So Z into modulus of Z of 1 is also equal to 1. Hence Z is 1, and also modulus of Z is not equal to 1. So your answer will be D. It is a set where Z upon modulus of Z will be equal to 1, but Z will not be equal to minus 1. A man walks a distance of 3 units from the origin to the northeast at a direction of 45° east. From there he walks a distance of 4 units towards northwest, 45° angle, to reach a point P. Then find the position of P as per the Arvin's diagram. Okay. Let's say this is your starting point. Here there is point P, and here there is point Q. Joining both of them. The angle here is pi by 4. Distance is 3. Here the distance is 4. Here your angle will be pi by 2. OP vectors we have done. OP is equal to OQ plus QP. Also, OQ is equal to modulus of OQ into E I pi by 4 is equal to plus 3 I pi by 4 because OQ is 3. The distance is 3. OP is perpendicular to OQ. Therefore, OP is equal to OQ upon modulus of OQ into OP I pi by 2. So therefore equating 3 E I pi by 4 upon 3 into 4I, that is 4I E pi by 4. So the answer is D, 3 plus 4I E I pi by 4, because from 1 3 E I pi by 4 plus 4I E pi by 4 is equal to 3 plus 4I E pi by 4. E I pi by 4. If modulus of z1 is equal to 1 and z is not equal to plus or minus 1, then all the values of z upon 1 minus z square lies on. Okay. So let z be equal to E I theta, first assumption. Z upon 1 minus z square is equal to E I theta upon 1 minus IE 2I theta is equal to E I theta upon 1 minus cos 2 theta plus I sin 2 theta, A plus BI. After that, E I theta upon 1 minus cos 2 theta minus I sin 2 theta, that is equal to E I theta upon 2 sin square theta minus 2I sin theta cos theta. E I theta upon 2 sin theta common, you get sin theta minus I cos theta. Again, that is E I theta upon 2 sin theta, E I theta minus pi by 2. So E I pi by 2 upon 2 sin theta, that is equal to cos pi by 2 plus I sin pi by 2 upon 2 sin theta, that is I upon 2 sin theta. So here it lies on y-axis as because your answer is I upon purely imaginary, so it lies on your y-axis. Z plus 4 modulus is less than or equal to 3, then the maximum value of z plus 1 is, so z plus 4. Here z lies on or inside the circle. So let's draw our axis. Your y-axis, this is your x-axis, this is your origin, and draw a circle. Let's say this is your point -4, 0. This is your point A, and the coordinates are -1, 0. Okay. So either it will lie on the circle or inside the circle, where center is -4, 0, and your radius will be 3 units. So maximum distance will be 3 plus 3, that is equal to 6 units. Okay. So the answer is E. The conjugate of a complex number is 1 upon I minus 1. Then the complex number is very easy. Modulus of z 1 upon I minus 1. So z is equal to modulus 1 upon I minus 1, that is 1 upon I minus 1 minus I, that is minus 1 upon I plus 1. Yes, our answer is D. If modulus z minus 4 upon 2 is equal to 2, then find the maximum value of z is equal to, so alpha minus beta is less than or equal to alpha minus beta. Here your values are given. Z minus 4 upon modulus of z is less than or equal to z minus 4 upon z. So z minus 4 upon 2. Let modulus of z be equal to r greater than or equal to 0, then r minus 4 upon r will be less than or equal to 2. So minus 2 less than or equal to r minus 4 upon r less than or equal to 2. Taking first two terms, so minus 2 less than or equal to r minus 4 upon r less than or equal to, that will give you r square plus 2r minus 4 greater than or equal to 0. So factors for r square 9 plus 2r minus 4 equal to 0, minus b plus or minus root of b square minus 4ac upon 2a. So that is minus 4 plus or minus root 2 upon 2 into 1. That's 4 plus or minus root of 4 into 5 upon 2, that is minus 4 plus or minus 2 root 5 upon 2. So the factors are 1 plus or minus root 5 upon 2, but roots will lie, your roots will be less than or equal to 1 plus or minus root 5. So from 1 and 2, root 5 minus 1 less than or equal to r less than or equal to 1 plus root 5. Hence, maximum value root 5 plus 1. Let z be equal to x plus yi be a complex number where x and y are integers. Then the area of rectangle whose vertices are the roots of the equation z raised to minus 3 plus z raised to minus 3, that is equal to 350. Okay, so z modulus of z cube plus z modulus z cube is equal to 350. Z modulus of z square plus z square be equal to 350. 2 of x square plus y square, x square minus y square be equal to 350. So x square plus y square, x square minus y square is equal to 175. X square is equal to 16 or y square is equal to 9. The roots for x are plus or minus 4 and for roots y are plus or minus 3. Your area of rectangle is equal to 8 into 6, that is equal to 48. So your answer is A. Z is equal to cos theta I sin theta, then the value for 15 summation of m is equal to 1 I imaginary part, that is z raised to 2m minus 1 at theta is equal to 2 raised to 0 is. So we have z is equal to cos theta plus I sin theta, that is equal to I e raised to theta. So 15 summation of m is to 1, imaginary part of 2z raised to 2m minus 1 equal to 15 summation of m is equal to 1, imaginary part of e I raised to theta 2m minus 1. So that is 15 summation of m is equal to 1, imaginary part of e I raised to 2m minus 1 theta. That is 15 summation of m is equal to 1, imaginary part of cos 2m minus 1 theta plus I sin 2m minus 1 theta, sin theta plus sin 3 theta and so on. Instead of sin 3 theta, I am replacing it by sin, let's say common, theta plus sin again is common, so 15 minus 1 2 theta upon 2 sin 15 2 theta upon 2. So that is sin 15 theta sin 15 theta upon sin theta. So that is theta is equal to 2 degrees sin 30 sin 30 upon sin 2 theta, that is equal to 1 upon 4 sin 2 theta. The answer is D. The number of a complex number z such that modulus of z minus 1 is equal to z plus 1 is equal to z minus I is equal to So let's start with let z will be in the form of x plus yi. Now modulus of z minus 1 is equal to z plus 1. So x plus yi minus 1 modulus, that is equal to x plus yi plus 1. Therefore that is equal to x minus 1 the whole square plus y square is equal to x plus 1 the whole square plus y square. So x minus 1 the whole square plus y square is equal to x plus 1 the whole square plus y square. Hence, simplifying the equation, we get 4x is equal to 0, therefore x is equal to 0. At the other side, z plus 1 is equal to z minus I. So x plus yi plus 1 is equal to x plus yi minus I. That is equal to root of x plus 1 the whole square plus y square is equal to x plus y minus 1 the whole square we are simplifying the equation. We get 2x is equal to minus 2y. Here y is equal to minus x. Lastly, modulus of z minus 1 is equal to z minus I. So root of x minus 1 the whole square plus y square is equal to root of x plus y minus 1 the whole square. So x minus 1 the whole square plus y square is equal to x square plus y minus 1 the whole square. Therefore 2x minus 2y, x is equal to y. So only two coordinates, that is 0, 0 will satisfy our equation. So our answer for complex number z, so z will be equal to, but the answer is B. If alpha and beta are the roots of the equation x square minus x plus 1, then alpha raised to 209 plus beta raised to 209 is equal to, so x square minus x plus 1 factors using quadratic equation, x is equal to 1 plus or minus root 3i upon 2. So alpha is half plus I root 3 upon 2 and beta is half minus root 3 upon 2. Alpha is cos pi by 3 plus I sin pi by 3 and beta is cos pi by 3 minus I sin pi by 3. Therefore, alpha raised to 2009 plus beta raised to 2009, that's equal to cos pi by 3 plus I sin pi by 3 raised to 2009 plus cos pi by 3 minus I sin pi by 3 raised to 2009. So cos 2009 pi by 3 plus I sin 2009 pi by 3 plus cos 2009 pi by 3 minus sin 2009 pi by 3. So 2 times of cos 2009 pi by 3 is equal to 2 cos of 668 pi plus pi plus 2 pi by 3. We have simplified the equation. Now this is nothing but 2 cos of 180 plus 2 pi by 3 minus 2 cos of 2 pi by 3, because cos of 180 plus theta is minus cos theta, so that is minus 2 into minus half values, that is equal to 1. So the answer is C. Next, let Z1 and Z2 be two distinct complex numbers and Z is equal to 1 minus TZ1 plus TZ2 for some real t with where t is greater than 0, less than 1. If argument for W denotes the principal argument of a non-complex number or non-zero complex number, then following. Alright, we're starting here again with Z. Now what is your Z here? 1 minus t Z1 plus t Z2 upon 1 minus t plus t. So your Z lies on the segment joining Z1 and Z2. Let's draw a segment. This is our Z1, this will be our Z2, this is your t, 1 minus t, Z2. So modulus of Z minus Z1 plus Z minus Z2 will be equal to Z1 minus Z2. So in the form of determinant we get Z minus Z1, Z2 minus Z1, modulus of Z minus modulus of Z1, modulus of Z2 minus modulus of Z1. So yeah, angle subtended at Z1 by Z, Z2 will be equal to 0. So Z minus Z1 upon Z2 minus Z1 will be purely real. Why? Because the points are collinear lying on the same segment. Argument will be same if taken in sequence. So the answer will be 3 of them, we will say either A or C or D.